number?
Shall we stop at number?
Okay. So we looked at number one. Number one was SI units, isn't it? We have to pick joules because we are looking at energy, isn't it? Then we looked at elastic modulus.
So we stopped at number 3. So now we're in number 4. We're in number 4 now, sir.
Okay, number 4.
Yes, sir.
Okay. So let me get the question for number 4.
Opongo.
Are you there?
Yes, I'm here.
Okay. So let's go. Chika, are you there?
Yes, I'm here.
So let's continue then.
Okay, I should read the question. So I'm reading the question now. The property of a body to remain at rest or to continue in uniform motion in a straight line is called A, momentum, B, inertia, C, impulse, D, energy. The answer is B, inertia. Sir, did you hear? Hello, sir, did you hear me? Sir. Hello.
Yes, I can hear you now.
So I said the property of a body to remain at rest or to continue in uniform motion in a straight. Hello, sir.
Hello, sir. I don't think she's active.
Yes, how are you?
I'm fine, sir.
Sorry,
I
my
don't think the
my network was
okay.
so bad I had to change it, but it's okay now.
All right.
But were you able to see my screen
So
the
the
last
girl that
time?
was reading the question paper.
Yeah,
Yes, I saw the screen. I saw everything.
okay. So she's joining back now.
All right.
So once she joins back, let's continue.
Okay.
Yeah, Chika here.
Yes, I said the answer is initial.
Inesha, good. My network was so bad I had to quickly change it so that I can log in. So the question says the property of a body to remain at rest or to continue in a uniform motion in a straight line. It's called, you remember we did this, was it last week?
Yes, I remember.
Yeah, it was part of the thing. So it is actually called inertia.
Yeah.
There we also learned
Number
about momentum and about energy. So energy is the ability to do work, and we say that energy is equal to force times distance, and impulse is simply force times time, and momentum is
Yes.
mass times velocity, mv. Impulse is ft, energy is ft. Whereas inertia is the property of a body to remain at rest or to continue in a uniform motion in a straight line. That very property that makes a body not to want to move, or if it is moving, to continue moving in a straight line. So that property is known as inertia. Are we clear on
Okay,
that?
Sam.
Emmanuel, are we clear on this?
Yes, sir.
Yeah.
Yes,
In our
sir.
past
Yes, sir.
question, we normally try to get the concept surrounding the very question, so that in case if you see any other problem relating to that, even if it's not that very problem, you'll be able to sort it out. Okay, so let's
Number
move
5.
to question number 5. Yeah.
During a training
Okay.
session. So is there any need of me reading it?
Yeah, I think it's always good you read it. Like, it makes it more
During a
relatable.
training session, two footballers pass. Okay, size the same.
You say?
Should I
Read it so that
continue?
we understand it as you're reading. Yeah, please.
Okay. During a training session, two footballers pass a ball repeatedly between each other. The to and fro motion of the ball is not simple harmonic motion because acceleration of the ball is not directed towards a fixed point. Restoring force is not directed towards the center. Acceleration of the ball is not directly proportional to the displacement from the fixed point. Which of these statements above are correct? I only. I only. I and I only. I and I. So I'm done.
Okay. So which one is the most likely answer?
I don't understand this question too.
Okay. You see, that's why I say you must read the question. So, like, if you did not understand the question, the only way to understand it is by reading it. Okay, so let's read it through again. During a training section, two footballers pass a ball repeatedly between each other. So you have one footballer here, then you have the other footballer here. So they have a ball, they are passing it to each other. So the ball is moving from one person to the other, to and fro, similar to what a simple pendulum or a helical spring could have done. You understand? But there's
So
a basic problem with this. So this motion, why is it that it is not a simple harmonic motion? It's a to and fro. Every to and fro motion, like this is a simple, this is what we call simple pendulum. So it has this ball here. If you displace this ball, it will keep moving like this on its own. This is another simple harmonic motion. This is a helical spring. If you tap the load here, it will continue moving up and down. This is another one. If you tap the string of the guitar, it keeps moving to and fro. But these are two footballers. Can you see two of them?
yes, sir.
So these are two of them still moving the
Yes.
ball to and fro. But what's the basic difference between this kind of motion and the one that is here?
It is not
So
directed towards the fixed point.
okay, you say because acceleration of the ball is not directed towards a fixed point. That's a then I says restoring force is not directed towards the center. Okay. Then this one says acceleration of the ball is not directly proportional to the displacement from the fixed point. Okay. Which of the statements above is correct? So, number one says acceleration of the ball is not directed towards the fixed point. Here, the acceleration is not actually directed towards the fixed point because you just shoot the ball, it moves. If not for this guy here, it will continue moving. So there is no direction of acceleration towards any fixed point. So the ball is actually coming back simply because this other guy is shooting it. But it does not have any mechanical ability to have returned on its own. Just like this one, the acceleration is directed towards this fixed point because it keeps moving up and down over this area. This one too, if you tap it, it will keep moving like this. So the acceleration is directed towards this fixed point, the same as this string, but here it's not the same case.
Okay,
And
sir.
also the acceleration is not directly proportional to the displacement. This one, the acceleration is hugely dependent on whether this person is touching the ball. But here, the acceleration is directly proportional to the displacement. Depending on how you push it, that determines how it accelerates and comes down. So that makes option A the closest to being the answer. So it's not every to and fro motion that is a simple harmonic motion. Simple harmonic motion is only the to and fro motion that uh, can sustain itself, not by human beings like these two people are kicking the ball. Is that clear?
Yes, sir.
Okay. So
Yes.
let's move forward. Oh, I hope my list is in. I think my list is not in order. After 5, what's the next one? 6. Okay. Oh, yeah, read out 6 from your side. Let me.
A dam is able to hold a large quantity of water because of its wall is A, thickest at the top, B, thickest at the middle, C, thickest at the bottom, D, of the same thickness throughout.
Okay.
So my answer
I
is
think
D.
this is not captured. Is what?
D, thickness throughout.
Thickness throughout. Okay. You know what we are gonna do? Can you continue
No.
from? Let's continue with the ones I have here, so that you can have a proper explanation. Because we are definitely not finishing all of them, so that when we meet again, I'll add up the rest of the questions.
Okay, sir.
Complete now. Okay, it's like it's complete. Wait, let me. No, it's still 46. So let's continue from. Let's see. Mm, let's continue from 11. Check 11.
An
Just
object
tick
at
out the one
rest
that we've done. Make sure
is
you
said
tick the
to.
ones we've done. Yeah?
Okay, sir.
So that
Uh,
when I hook up with them.
so an object at rest is said to
Okay.
possess A, potential energy, B, kinetic energy, C, chemical energy, D, electrical energy.
Okay, that one you should know that one very easily, Abby.
Potential energy.
Good. Potential energy. Every object at rest, that's the kind of energy they possess. Potential energy. Kinetic energy is energy due to motion. Then chemical energy is energy in the food that you eat. And what sort of other energy is there?
Electrical.
Electrical, yeah, due to flow of current. Okay. So
Okay,
let's
sir.
look at
What's
number
other
15.
question?
Let's look at 15. Let's look at 15.
The ice point on this absolute scale of the temperature is
Okay. The ice point on the what?
on the absolute
Absolute
scale of
scale.
temperature.
Okay, okay. So when we say absolute scale, which one is the absolute scale? Is it the
The
Celsius or
absolute
is it Kelvin or Celsius or what?
absolute scale is Kelvin.
Kelvin, good. So what's the ice point?
So it will be 27, 273, sorry.
273, isn't it?
Yes, sir.
So that's the ice point. Ice point is normally 0 degrees Celsius. So when they ask you ice point in Kelvin, simply if you can convert that 0 degrees Celsius to Kelvin, which is simply adding 273, and that will give us 273. Are you clear on that?
Yes, sir.
Okay. So let's look at 16.
So we question.
Okay. So let's continue.
Number 16.
Yeah.
Which of the following factors does not increase the rate of evaporation of water in a lake? A. Increase in pressure of the atmosphere. B. Rise in temperature. C. Increase in the surface area of the lake. D. Increase in speed of wind. The speed of wind affects
So what is
Increase in the speed of
you say?
it affects. So what do
the
they mean
answer
by
is
the
D.
surface area of the lake? So what do they mean by the surface area of the lake? Hello.
Yeah, I can hear you.
So what do they mean by the surface area of the lake?
Okay, surface area of the lake simply means the area that is exposed to the atmosphere. That's the top of the lake. So if this is the lake with water inside it, all this top of the lake is the surface area. So the more the area that is exposed to the atmosphere, the more likely it is for water to leave that place and enter the atmosphere. So increase in surface area will increase evaporation. Increase in wind speed. Once wind is blowing across the water, more will be evaporating. The rise in temperature naturally will cause evaporation. So that makes those three most likely things that are factors that will cause more evaporation. So factors, temperature, surface
So
area,
why
and
is
speed
it
of
not
wind.
increase in pressure?
Increase in pressure will not even make the evaporation to go down. It will cause less of evaporation. So it will cause the opposite effect.
Okay, sir. Okay,
So
sir.
the factors that make evaporation to be more is temperature. Once the increase in temperature, the molecules will gather energy and want to move. Surface area, because of exposure of more area to let the molecules to move. And also wind speed. The speed of the wind will drag the water up. Yeah, so let's look at question number 17.
The pole of a simple pendulum takes 8 seconds to complete 10 oscillations. Determine the frequency of the oscillation. of the bulb.
Okay. So that one is pretty simple, isn't it?
Yes, sir.
So which option are you picking?
The answer there will be B.
There's number of oscillation over time, isn't it?
Yes.
Okay. So frequency is simply number of oscillation over time. And that is 10/8. Giving us 1.25. Okay. So that's 17. So let's look at question number 18.
Number 18. So should I read it?
Yeah, please.
The diagram
It's like you don't
above
want to
illustrates.
read. You don't want to read.
No, sir, I want to read. The diagram above
Okay.
illustrates the mercury in glass thermometer used for determining the temperature of the room. Use the data on it to determine the room temperature. A 3.3 degrees Celsius, B 7 degrees Celsius, C 13 degrees Celsius, D 30 degrees Celsius.
Yeah. So what do you think is the answer?
I don't know.
Okay. So the total length, can you see the total length from here to here?
Yes.
Can you see the total length? It's 10 cm. You understand? Total length from here to here is 10 cm. And that is what is represented from here to here, 10 cm. But the reading is just reaching, got up to this place, which is below half. Can you see that? Below half. And it's around 3 cm. Can you see that?
Okay. Yes, sir.
So if the hole is 10 and this little is 3 cm, you understand? Simply telling us that it's
Yes.
around 30 degrees. Instead of if the hole is 10, I know that the hole is also 100 degrees Celsius. If you're looking for like 3 cm alone, simply tells us that it's around 30
Okay,
degrees
I
Celsius.
understand now.
Understand now, ba? The total
Yes,
is
sir.
10 cm and the total temperature here is 100. If you're taking only 3 cm out of 10 cm, simply means 30 out of the whole 100. And that's why 30 is the answer. So you can see that some of the problems are not straightforward problems. There are problems that you need to apply a little intelligence and you'll be able to solve them out.
Yes, sir. So these remaining questions, we'll solve them in the next class.
Yeah, in the next class. Because me
Okay,
already,
sir.
I'm even tired. I'm just forcing myself to finish up this one. So that we know that once we meet up again, we are solving the remaining ones. I want us to have background before we solve them so that you will learn a lot from the background that we have. Okay, so let's look
And
at
number
19.
19. Frequency is measured in hertz.
Yeah. So that one is pretty easy, isn't it?
Yes.
Okay. So frequency is measured in hertz. It's not meter per second. Meter per second is for velocity. It's not in seconds. Seconds is for time. It's not in farad. Farad is for capacitance. So it's actually hertz. Frequency is measured in hertz. Abby?
Yes, sir.
Okay, so we've been able to go up to, okay, so let's look at 20.
Which of the following electromagnetic wave is the most energetic?
Okay, which of the following electromagnetic wave is the most energetic? Okay, what
A.
are the options?
Radio waves. B. X-rays. C. Gamma rays. D. Ultraviolet rays.
Okay. So which one is the most, which of the
I
following
don't know.
electromagnetic most energetic?
So I
Okay,
don't
that is
know.
the one that, okay, in the subsequent class, I'm going to give you a, yeah, list that arranges them in so that you can have a good picture of it. Okay, so let's move on. Let me see which one I'm going to look at. Okay. So when we cover
Rainbow
waves,
formation is a natural phenomenon illustrating that white light A splits into three components after rainfall. B is dispersed by glass prisms. C splits
we are
into
looking at
its constituent.
46. So
Oh,
let's look at 46.
which of the following particles may be emitted in the process of natural radioactivity?
Okay.
That is A.
So which is they have alpha particles and beta particles. You have alpha particles and X-rays.
Alpha
You
particles
have
and
beta
beta
particles
particles.
and X-rays. You have gamma rays. The three
Alpha
emissions
particles.
that can come out from, yeah. So for, yeah, you're correct. For natural radiation, it has to be alpha, beta, and gamma rays. Those are the three radiations that come from, uh, what's it called? Natural radiation. So let's look at 48, 49, and 50. Around
Which of the following radiations has the longest wavelength? A. Gamma ray. B. Radio wave. C. Infrared ray. D. X-ray. I think it's X-ray.
okay, yeah. So I think this is the diagram I wanted to show you that shows the that answers the you remember the other one that we answered that asks which of the following waves is the most energetic?
Yes, sir.
Do you remember? That's question number what? Is it 20 or
That's question
19?
number 20.
Check 20, okay. So this is the diagram of the electromagnetic spectrum. Hmm? Are you listening?
Yes, I'm listening.
Good. From one side, it has the radio waves, then the microwaves, then the infrared, then the visible light, then the ultraviolet light, the X-ray, and the gamma rays. Hmm? This side,
Okay.
they are known as the ones with the longest wavelength. But the ones with the longest wavelength, they are not the most powerful or the most energetic. The more the wavelength, the lesser the energy. So the ones that have more energy are the ones on this other side. And that's why gamma ray was our answer. Remember that gamma ray, did we pick gamma ray as the answer?
Yes, sir.
Chika, did you pick gamma ray as the answer?
Yes, sir.
Good. So whenever they ask you in the electromagnetic spectrum, which one has the highest energy? If it is not gamma, if you don't see gamma as the option, the next one should be X-ray, then ultraviolet. Is that clear?
Yes.
But when you ask the one with the longest wavelength, then it is radio wave this side. You understand? So this side have the more wavelength, but in terms of power or energy, then you talk about gamma ray, or in terms of higher frequency, one can penetrate deeper. Then you talk about gamma ray, X-ray, ultraviolet. Are you clear on that?
Yes, sir.
So this is the diagram I said in the next class I'll give you, but I didn't know I already have it in this question. So you should always know that in terms of wavelength, this one has the longest wavelength, and that's why you are having it in the denomination of like 10 to power 4, 10 to power 2. Whereas this one, the wavelengths are very small. This is around 0.0000, is very small, but this is around 10,000. So this one, the wavelengths are very small, but they have higher power to penetrate. They have more energy. So gamma ray, X-ray, ultraviolet are very powerful. The visible light is around the middle. But for higher, longer wavelengths, we talk about radio waves and microwaves. So with this now in mind, which is the answer?
The answer is radio wave.
Perfect. So radio wave has the longest wavelength in the electromagnetic spectrum, whereas gamma ray has the least, but it is the most energetic. Are you clear on that?
Yes, sir.
Okay, so let's look at question number 49. Question number 49.
In which of the following field is radioisotope not used? A. Medicine. B. Oil industry. C. Agriculture. D. Weather forecast.
Okay, so you're asked where you don't need radioisotopes.
Yeah.
You understand? So it's basically they're asking you about the applications of radioisotopes or uses of radioisotope. Where are they used and where are they not used at all? Is that clear?
Yes, sir.
So where do you think that you don't really need radioisotope to work with?
You don't really need it during weather forecast.
Yeah, you don't need it in weather forecast because you have other equipment that you can use for your weather forecast. But you need radioisotopes in medicine, need them in
So what are
oil industry.
radioisotopes?
Radioisotopes they are isotopes that you can use in affecting radioactivity. So once you need radiation, you understand, it's radioisotope that enable radiation. Is that clear?
Yes, sir.
Yeah, things like uranium and all those things that can cause radiation. So the isotopes are known as radioisotopes. So they can be applied in medicine, they can be applied in oil exploration, they can also be applied in agriculture, but not in weather forecast. Are we clear on that?
Yes, sir. Number
Can
50.
also be used in energy production. There are 50. Lastly, for today, let's look at number 50.
A nuclide is represented by dot. Determine its neutron proton ratio. Oh my God.
Okay, a nuclide is represented by this. Determine its
They
neutron
don't
to
give me
proton
the
ratio.
thing.
Hmm?
They didn't give me
They
the
did not give you the
value.
what?
The value
The value of what?
by what is represented. The diagram is not here in my own. Like the boron,
Can't get.
the boron is not here. They just put represented by dash in my own.
You mean in your own?
Yes, my past question. They didn't give it to me.
Okay. So let's sort it out from the one I have on my screen. So they say a nuclide is presented by this B. Up here is 70, down here is 32. So determine the neutron proton ratio. So what is always in the up is the mass number, whereas what is down is the atomic number. Atomic number is simply the number of protons. So if you now want to get the number of neutron, it has to be the number of mass number minus the atomic number, because it's simply the proton and the neutron that makes up the mass number. So if you do 70 minus 32, you're going to get 38. That means the neutron is 38. So that means neutron is 38 and proton is 32. Are we clear on that?
Yes, sir.
Chika, do you understand?
Yes, I do.
This mass number 70 is simply neutron plus proton. But they already told you that proton is 32. That means neutron should not be 70 minus 32, which is 38. You understand? So you can simply
Yes,
say
sir.
that the ratio of neutron to proton is simply 38 is to 32. And that is why we have here 38 is to 32. Is that clear?
Yes, sir.
Then if you want to get a ratio, you simply divide by the smallest one. So if you divide 32 by 32, you get 1. If you divide 38 by 32, you get 1.18 something, which is approximately 1.2. You understand? So we simply have 1.2 is to 1. And that's why we have here 1.2. Because it's simply 1.2 is to 1. So the ratio is simply 1.2 over 1. 1.2 is to 1 is the same thing as saying 1.2 over 1. If you divide 1.2 over 1, you simply get back 1.2. And that's why C is the answer. Is that clear?
Yes, sir. It is.
Okay. So I hope you know our channel on YouTube. Chika, do you know my channel on the YouTube?
Yes, sir, I do.
Okay, the name is Tclassified.com. It's very, very good for you. Because the questions here, we did not just give you the answer alone. We give you the answers in
Explain.
context. The answers are in what? Context. So once you see the answer, you'll be able to like answer other questions for yourself.
Okay, sir.
So it's
Thank
good
you.
you know the channel, like, and I'm always updating it. So even the newer, what's it called? The newer past questions like 2020, all of them. If you are checking the channel every day, you see that I'm always updating it every day. We are solving past questions, we are updating,
Sir,
making it possible for you. Yeah, Emmanuel.
sir, some of the tutorials don't have audio. Some of the
So they
tutorials
don't
don't
have
have audio.
audio.
Like the last physics you posted, you don't have at the beginning, at the ending, you
Yes.
don't have audio. You'll be talking, but I won't be hearing what you're saying.
Yes, I saw the comment. Was it you that commented about the audio?
Yes, no audio in the tutorial, physics tutorial.
Okay, you said it's from our 3 down.
Hello?
You said it's from the third hour number 3 down, but
Yes.
okay. I think it's
From
actually from
the
my
physics tutorials.
what's it called? The
Yes, once the thing reached like from
I think it's from is from the when I got it back from internet and tried to put them together. I joined them up. I those lectures are already on our channel before. Do you understand, Emmanuel? I want to show you something. Emmanuel, are you still there?
Like he's not here.
But I can still see him on the Zoom. I want to show him where he can see the volume.
Okay, it's
Emmanuel,
here.
are you still there?
So I want to go and finish up my
Yes,
assignment.
yes, okay, yes, I
Yeah,
know. I saw
yeah,
some of
you
the,
can go. You
yes,
can
I
go
saw
finish
some of
up
the
what
story.
you do. Let
Yes,
me show you, Emmanuel.
yes, I
Emmanuel,
Okay,
understand.
so
yeah, once you
ah,
get to the channel, if
No,
you go to
I can hear
physics,
you.
okay,
Charlie,
if
I
you
what
can
did
hear
you
you. I can hear
say?
you.
who is talking
Yes,
now?
I can hear you.
Okay,
I'm
so if
trying
you
to
go
say
to
I'm leaving.
physics, Emmanuel, are you listening? If you go to physics here, that is a
Yes,
playlist, you get all the
yes.
volume. The volume problem, I think it
All right.
occurred
Okay.
trying
Okay.
to put the videos together, but I will try and redo it again and post again and make sure that it's having volume. Okay.
Okay.
Oh, yeah, now. Good.
Okay. No
Thank you.
problem, sir. Thank you.
Yeah, let me go rest. See you some other time. Thank you.
All right, sir.